Well, hello. Welcome back to the Elementary Psychometric Laboratory. Today's topic will be test validity, which is to say, well, the extent to which the test does what it claims to do. In a sense, I've already given away the entire talk, but there are some details to delve into naturally. Note this is not a how-to talk, so calculation of such things as the standard error of the estimate will be found in other presentations. This is a more general presentation here. All of which said, let's see what we've got to share. Yes, an overview. So, again, I sort of gave the game away already. The simple definition of validity is the extent to which a test or measure does what it's supposed to do, measures what it claims to measure. What does the label on the box say when you buy the test kit? Does it live up, or how well does it live up to that name? It's not all or nothing, of course. And this is very different, though easily confused, with test reliability, the subject on which we've spent a number of sessions together. Reliability only refers to the extent to which the test measures something or other. When we know how reliable a test is, we know how well it measures whatever the heck it is that it actually measures, but we don't know what that is. And you can't just trust the name on the box. So validity is taking the big step forward of addressing that really all-important question. Now, there is a little complication here. Of course, there's always a little complication. Many, if not most, tests are used for many different purposes. I mean, even a simple measure like, let us say, a self-report scale of depression could be used to help to identify people who are clinically depressed, suffer from major depressive disorder. It could be used to track change or hopefully improvement over time in people who are depressed. It could be used to quantify the extent to which non-clinical cases people felt some degree of depressive affect. When you start looking at more complex measures, multi-scale inventories like the MMPI or major IQ tests like the Wechsler scales, they may be used for multiple rather different purposes. Using an IQ test to predict grades in middle school is very different from using it to predict performance success in a training program in the military, which is different again from using it to predict how well a person will be able to make use of a cognitive rehabilitation or therapy program. There's so many possible uses. And the fact is that simply because we establish that a test has validity for one of these purposes does not speak to the degree to which that will generalize to the other purposes. So you can't really say there is a single validity coefficient for a test. What you can say is that it has a known degree of validity for a given purpose. Now, reliability. We spend so much time fussing about reliability, and at the end of the day, we discover that it isn't even what we really directly care about. Why? Why do all that? And the simple answer to that question can be given in different languages, so to speak. So I'm going to try first off with a logical definition of why reliability matters. Reliability is what's known as a necessary but not sufficient precondition for validity. That's the language in which philosophers will speak, logicians will speak. It happens to be a cloudy afternoon just now. There has actually been some rain. Well, a cloudy sky is a necessary precondition for rain. If there are no clouds in the sky, you're not going to get rain. Let's forget about sun showers for a moment. But it's not a sufficient condition for rain because you can have cloudy skies for days on end without rainfall. Likewise, if you don't have an adequate degree of reliability, you're not going to have a very valid test. If it's not measuring anything, it's not measuring what you want. If you wanted to put this in more mathematical language, it would come out something like this. Reliability sets an upper limit on validity. Remember, in math, you have that idea of a limit, that the curve will never go past that line, no matter how, the asymptote, no matter how far you pursue it. Well, reliability is creating the ceiling, as it were. So if you have a test that's low in reliability, it's not going to be very valid for any reason, any purpose whatsoever, and you may as well not bother investigating it any further. But the mere fact that it is highly reliable does not guarantee that you're going to have a high degree of validity. So having established the reliability, we move on to try to establish or ascertain, just how valid the thing is. Now, there are separate presentations with how-to guides here, but I want to briefly address these subjects here as well. Typically, you're using a test to try to predict or classify someone based on some other criterion, some external criterion, something other than the test itself. So I have, a few examples here. You take an entrance examination and go into college, and the entrance exam is supposed to have some ability to predict your grades. You look at a seasonal forecast. How's the winter going to be? Or in this case, my example, the summer going to be. And then you look perhaps later at, how good was the wine produced in that province or county that year. Or you can, you have an ink blot test and the report based on an ink blot test, and you're trying to identify what a psychiatrist would diagnose the patient with. Now, in every one of these cases, this is the kind of thing you might design as a sort of validity check on the test, right? Does the entrance exam predict grades? Does the ink blot correlate with diagnosis? Does, do seasonal forecasts have any usefulness in predicting whether you should buy that year's wine and put it in your wine cellar if, unlike me, you have one? But what we often forget is that it's not only the test that has limited reliability, but also the criterion. Psychiatric diagnosis, grades assigned by professors, judgments of wine experts, and so forth. And neither being perfect, there are two sources of randomness here. So if we want to know how strongly it's possible for two variables to be correlated, like a score on an ink blot test and a psychiatric diagnosis, for example, you need to take that into account. And there's a simple formula for it, which is the square root of the product of their reliabilities. That's it. And again, a separate presentation goes into that in the how-to way. We also can, I'll blur through this very quickly because it is addressed in the other presentation. We can make a correction for that if we're interested on a theoretical level in how strongly two variables are correlated. So if, for example, I'm really interested in the relationship between what's known as achievement motivation, the desire to meet or exceed standards, and the behavioral pattern known as entrepreneurship, the tendency to start businesses, start new projects, et cetera. I don't have any direct way of measuring either of those. I only have indirect measures. So I might be using achievement imagery in stories a person has written. I might be using whether they actually start a business in the next year. Both of these could be considered to be fallible from the standpoint of reliability. So the result we get was attenuated by the limited reliability. That's the problem from the previous slide, right? What we can do is to make kind of a correction, kind of an upward adjustment here to see what the true relationship between the theoretical variables might be. So not everybody accepts this procedure, but it's generally considered to be okay as long as you fess up to what you're doing. And yeah, there's an equation for it. It's pretty straightforward. What did you get divided by what's the most you could have gotten? That's all it is. Now, again, not here because that's a separate how-to guide, but there are ways of calculating how much error is built into our predictions. So you predict an outcome. You predict my grade point average in the first year of college, or you predict how large a response I'm going to show to an antidepressant medication. That prediction is a point estimate. with a lot of play, a lot of error built into it. And what you want to know, similar to the standard error of the measurement that we studied earlier, is within what bounds is it likely that the true result will lie? Again, there's a formula for it. It's based on the standard deviation of the outcome, which of course makes sense, and the correlation between the test you're using and that outcome, which you could think of as the validity coefficient. So there's the formula again. Else separately, we'll look at how to crunch those numbers. Now we're going to get into the flavors of validity. And it's similar to reliability. There are different types of validity, and they arguably each in this case apply to most tests, though some may only apply to a limited subset. So it's content, criterion, and construct. There are subheadings under a couple of these, so be prepared for that. So content validity refers to exactly what you figure. It's the content of the test, what's in it, what went into it. Hopefully, there are people who know something about what you're trying to measure. There are experts out there somewhere, and they would have some idea what ought to go into such a test. So you're asking them. That's what it amounts to. It's expert judgment. This is relevant for virtually all tests, except for a little subset of tests that are developed totally empirically. There's no underlying theoretical construct of any kind, and you're just using it for one thing to predict something. That's uncommon. For most tests, though, this is only a first step. The fact that the experts say it looks good, that's great, but it doesn't mean it actually works. It just means the experts say, yeah, that should work, and then you just kind of hope the experts are right, but you can't just hope that. You have to run, further studies. The exception here is that there are certain things for which there is no outside standard other than expert judgment. The main example is certain academic achievement tests. What should you learn in a one-year survey course of Middle Eastern history? Presumably you should learn what experts in Middle Eastern history believe you should learn. Right? What else could there be? There isn't some magical outside thing we could use. Similarly, what should you learn in a statistics class? Well, you should learn what statisticians think you should learn. There, I suppose you could have an outside standard, and you could see how well somebody, performed as a researcher later on. But pure academic subjects, there's no obvious direct application. So establishing it, what you do is you try to get, a few of the experts on board with helping you out here. You send them, your draft of a test. They look it over and they give you feedback and tell you what they think you got right, what they think you either got wrong or left out or put too much of in there. And that's it. Because what you have to think of is this. There's a whole domain of knowledge for something like Middle Eastern history, huge domain. A good test samples that domain in such a way that if you have a certain level of overall knowledge in the domain, you'll perform at a certain level on the test. So does the test sample the domain well? Now, there are ways of quantifying this. We're not going into them in my classes. Maybe someday I'll create a video on it. But the most frequently used method was developed by Losch. I hope I'm mispronouncing his name or not mispronouncing his name, back in the 1970s. And essentially, you just have the judges look at each item on your test. It's most often used with achievement tests. And they rate it as essential, relevant, but not essential, or not relevant. And you have this formula where you come up with the content validity ratio for the item. Essentially, the more of them that call it essential, the better, the more likely it is to survive. So you can quantify it, and that is done more by professional achievement test developers, I think, than anyone else. But it's widely considered to be appropriate, but perhaps not essential. Sorry. Should say something about what's known as face validity. It sounds like content validity, but it's not. Face validity, unlike content validity, refers to whether the test looks good to someone who actually doesn't know anything about the subject. So if I don't know anything about, depression, or I don't know anything about, Middle Eastern history, or I don't know anything about creativity, does it look to me like a pretty good test of one of those things? This is not actually a form of validity at all. From a purely scientific standpoint, a psychometric standpoint, we don't care what uninformed people think about a test. We care about expert judgment, yes. We care even more about whether it really works. We don't care about someone who honestly doesn't know anything, their opinion. However, face validity is worth being aware of for two reasons, mainly because you can have a really lousy test out there, but if it looks good, people are going to take it seriously, and they're going to spread the word and be taking it like, oh, look at my feedback, I'm a yellow person, or something. Secondly, you can also occasionally run into problems where if you have a perfectly good test that just looks odd to the layperson, it can be hard to get people recruited, to take it seriously when they really need to. Now, criterion validity is really this kind of the centerpiece here, although not the end goal. A criterion is an external standard, some form of extra test behavior, as it were, something that we know is relevant, we know is important to what we're trying to measure. In some cases, you have a test that already exists that works pretty well. If you came up with a new intelligence test, you'd be rather foolish not to correlate results on your intelligence test with those on things like the Wechsler intelligence scales, the Kaufman assessment battery for children, or the Stanford Binet. Those already have well-established levels of validity, measuring something that we're calling intelligence. So your test ought to correlate pretty strongly with theirs. But of course, the more creative validity studies are not ones where you're just saying, look, it correlates with other tests of more or less the same thing. It's where you're looking for something, interesting, maybe even a little provocative, but obviously relevant. And really, that's the big research challenge that folks face is, coming up with a cool criterion, as opposed to what is sometimes called a crummy criterion. And I'm calling this the bread and butter of validity research because, yeah, that's what most of the studies you're going to read are reporting on. If it's development and validation of a scale, they report on, item development, reliability, and then they give you at least one good criterion validity study. And this does give you a kind of validity coefficient. You get a correlation, for example, between the test and the other variable, or some kind of regression equation or what have you. But again, remember that it won't generalize to new uses. It stays, kind of restricted to the thing that you've actually studied. So this is huge. This is what lots and lots of master's theses and doctoral dissertations and published papers in journals are all about. Now, it's broken often into two types. Concurrent and predictive. They're actually pretty easy to tell apart, and on a theoretical level, they're not that different. What's different is the time frame. That's all. Concurrent means at the same time. So I'm giving people the test and administering whatever the criterion measure is in more or less the same time frame. Might be in one session, might be a few days apart, but it's, there's no reason to think that anything would have changed in the meantime. So if we, have you complete a depression inventory, and later that day, perhaps you're interviewed by a psychiatrist who doesn't see the results of the inventory, because that would be contamination of the results, and the psychiatrist is diagnosing you, well, to what extent they match up is a good measure of concurrent validity. Predictive validity, as the name suggests, involves taking the test and then waiting a while until something else happens and seeing how well the test can or fails to predict that something else. So I could give you a depression inventory as you were about to begin a course of antidepressant medications and see whether, the patient's depression scores came down after 6 or 8 weeks on antidepressants, which would be, since we know the antidepressants have at least some moderate level of impact on depression, if in a sample of people depression scores came down, it would say, yeah, your depression test is performing as expected. Or if we gave you an intelligence test, or children an intelligence test in 3rd grade in September, didn't tell the teacher the results, and then looked at their final grades, or their achievement test scores the following June, you're using the IQ test to predict something. Now, the holy grail of all this, and I use that term advisedly, is what's called construct validity. This does become a very abstract concept, but it is nonetheless a very important one. A construct is a set of theoretical concepts, as it were, that are sort of woven together. So if something like intelligence is a theoretical construct, something like creativity is a theoretical construct, psychopathy is a theoretical construct. These are the things that psychologists are actually interested in. We're not interested in tests for their own sake. We might get to be after a while. I think that's kind of cognitive dissonance at work. But we're interested in what it is that we're trying to measure. So we're trying to study psychopathy. We're trying to study schizophrenia. We're trying to study Machiavellianism. We're trying to study whatever it happens to be. And the question becomes, how well does this test capture that complex construct? Now, as always, there's exceptions. Here, the only exception, as with content validity, is if you have a test that's developed entirely for a single practical purpose. Like, all I care about is predicting whether, after being released from prison, you're going to commit fresh crimes. And I'm not thinking about the meaning of the test. All I care is, does it work? There's no theoretical construct. But if I was using a measure of psychopathy to generate that prediction, that would be just one piece of developing a case for the construct validity of the psychopathy test. Psychopathy should, among many other things, predict recidivism. So this is the ultimate goal. And when I used the phrase, quest for the grail there before, it's sort of like, the old Arthurian legends. Generally speaking, you set forth on this quest, you are not going to ever attain the final goal. It's, like all the folks, intensely practicing, yogic meditations. The ultimate goal there would be to achieve freedom from the cycle of rebirth, but there isn't really an expectation that many of them are going to do it. But somehow, by practicing, your meditations, whether they are, Christian or Brahminical or what have you, you are purifying yourself in some sense. And, the quest for the Grail would purify the knights. And in a less spiritual sense, obviously, the quest to establish construct validity of a test, in a sense, purifies our sense of what the test is, and also may lead to changes in the test. So it's an ongoing case that we're building for the construct validity, rather than an endpoint that we reach and we say, now we're done. One way of trying to describe this, and this all goes back to the source paper on this, which was Cronbach and Meehl back in the early 1950s, is to think in terms of a so-called nomological net or nomological network. I like the simpler phrase web of meaning myself, but what you have are theoretical constructs, which are somewhat, for those of you who are students of the liberal arts, of the humanities, they're somewhat like Platonic ideal forms, right? These theoretical constructs relate to one another on a purely conceptual level. If we start from psychopathy, we're probably quite closely related to impulsiveness. We're quite closely related to aggression. We're quite closely related to manipulativeness. We're moderately related to sensation seeking. We're moderately to strongly related to grandiosity. We are more distantly related, perhaps, to, being less agreeable, even more distantly related to being a little less intelligent on average, or to intelligence, but a negative correlation. There's this whole network, in other words, like you can imagine it like a web, with each nodal point on the web represents one of these theoretical constructs, and then the threads connect them, and some are close together and some are far apart. Now, if I'm trying to measure a construct down here, on the mundane plane where we live, where we can actually give and score tests, it's trying to capture that highfalutin theoretical construct. So if we have tests of many of these constructs, they should relate to one another statistically about like the theoretical constructs should relate to one another. So my psychopathy test should correlate strongly with tests of impulsiveness, of narcissism, of aggression. It should correlate much less, if at all, with measures of, I don't know, let's say, well, intelligence, good example. It might be a weak negative one, but not a strong one. Oh yes, here's the psychometric cattail for us all. So that's the idea. Again, it sort of helps if you studied a little philosophy here, because it's sort of very, very Platonic, almost magical sort of thinking, almost mystical in its nature. So as you're doing this, notice that I said it should be closely related to some things and not really related to others. You're actually looking for evidence both of convergent and of discriminant validity. Convergent, converging together, so your test scores should correlate pretty well with scores on closely related constructs. Doesn't matter, by the way, this can be confusing, but it doesn't matter really if it's a positive or a negative, it's still convergent validity. So psychopathy, for example, should correlate positively with narcissism, but negatively with trait conscientiousness. Those should both happen. Discriminant validity refers to the fact that the test should not correlate with measures of only remotely related constructs. So my psychopathy scale shouldn't really correlate with probably much with intelligence, weak negative perhaps, shouldn't really correlate with tests of creativity. And again, none of this is all or nothing. What you expect really are patterns of stronger and weaker relationships, and you want to see it all, sorting out. Okay. Yeah, I have an example here with intelligence as well. Intelligence pretty strongly related with reading comprehension, only moderately to memorization, virtually not at all to personality traits like neuroticism. There came to be this idea of a multi-trait, multi-method matrix. So this was introduced by Campbell and Fisk, late 1950s, early 60s. What they pointed out, and to my mind thinking, by the way, there's a problem with this, which I'll get to, but what they pointed out is that some of the variance in test scores is because of what we're measuring. So I have a measure of reading comprehension. Some of what I'm getting is in fact measuring reading comprehension. Hurrah. But some of it is due to how I'm testing you. So, a multiple choice measure of reading comprehension may yield some subtly different patterns of results than, say, a short answer or free response, open free writing measure of reading comprehension. And that's not what I'm trying to do. So to the extent that I'm measuring multiple choice taking, I'm not measuring reading. So their very clever idea was that what you should do when you're setting up a big validity study is, like, you've got your test, which is supposed to be measuring this thing this way. Well, have another test of this thing some other way, and have another test of something else measured this way. So I'll have a multiple choice test of something other than reading, and I'll have a reading test that doesn't use multiple choice, but some different format. And then you do all the correlations amongst all the different measures. And what you should, find ideally is that the correlations for measures of the same underlying construct, personality trait or mental ability, should be stronger than the ones that are measuring different traits, but just using the same method. Here's a picture of how this can look. And yeah, it can be a lot. In this make-believe example, I think it's make-believe, you have 3 methods and 3 traits A, B, and C, methods 1, 2, and 3. And so you can calculate all the possible correlations amongst them. Those numbers in diagonals here are, I believe, reliabilities, but then, yeah, here we go. Or those are within trait correlations, yeah. And then, what you're hoping for is that when you're measuring trait A, the correlation with trait B is going to be strong, or with correlation with trait A using method 2 or trait A using method 3, those should be stronger than the correlations that trait A has with measures of traits B and C using the same method. So in this case, 0.57 and 0.56 should be greater than the average in here, which they are. Yeah. This gets pretty complicated. Mostly the numbers in these triangles you can ignore. It's going to be these sets along here that you're most interested in. Whew. Okay, what's my problem with it? And this is very much a personal professional opinion, so it's not something there's a widespread consensus on, is that I think that applications of this method can fall victim to the so-called Jingle Fallacy. The Jingle Fallacy is that in fact, it is the Jingle Fallacy, my mistake. The Jingle Fallacy is the tendency to think that 2 tests must be measuring the same thing because they have the same name on the box. Jangle is when you make the mistake of thinking they must be measuring different things because they have different names. The problem here is that when you use different measurement methods, sometimes you're really measuring different things. And I'm very aware of this because I happen to be interested in so-called performance-based or projective personality tests, which in fact, in many cases, seem to be measuring something different than what you get on self-report personality tests. So if you constructed a multi-trait, multi-method matrix, which has been done for a variety of personality tests, theoretically measuring the same underlying construct, it won't look very good, but that may be because different ways of, say, measuring achievement imagery or achievement motivation, rather, are really not measuring the same thing. Okay, so wrapping up, validity, this is the real thing we're after. Reliability is simply an essential step along the way. The validity simply indicates how well the test does what it's supposed to do. But since tests have often many things they're supposed to do, validity is established for each one. Like an employee who has 5 different tasks, you're not equally good at all 5 tasks. And validity is categorized under these 3 headings: content validity, essentially expert judgment; criterion validity, how well it correlates with or predicts relevant extra test behaviors; and construct validity, how well it captures some underlying theoretical construct. All of that being said, we have wrapped it up for the day, and we're going to stop now.